Okay, so yesterday, because it was kind of all, it is, oh no, today's the 6th. What am I talking about? I got kind of confused as far, like, ninth period took a little longer with the scope quiz, and we didn't get nearly as done or as far in the notes. So I'm trying to remember exactly where we're at with talking about them. Did we do the standard unit vectors? On this one, that I is equal to and the j is equal to?
Yeah.
Okay, because it was, let's see, I, so it's 1, 0, and j was 0, 1. Okay, but we skipped the proof of it, correct?
No, we did not.
Okay, so did we do?
We did all that. The only thing we didn't do is the trigonometric forms of any vector.
Okay, all right, so let's just do one of these. So like if I want to rewrite it as a linear combination, okay, that literally is you're taking it, you take out of your component form, which is basically your arrows that way, and then you write as the AI plus, so 2I plus 5J. Okay? So the only difference is if you have it as RS, what do you need to do first? Yeah, put it into the component form. So we would have RS is going to be what? -9 and -5. That's going to give me -14. And 8, 6 is going to give me 2. So that means in the linear combination, I'm going to have -14I plus the 2J. Does that make sense?
Is that it?
Yeah. That it's literally just a different way that you can write it. Okay? If you're trying to write it as a linear, the way I always kind of thought of it is I always think of vectors as like on the verge of like a 3D kind of thing, and then linear I think of as a 2D kind of thing. And so to me it's just a different way to write the exact same thing. Okay, cool? Alrighty, then, oops, get to my right page so I have my calculations done. Oh, I already took that out. Okay, so and then we talked about the trig forms of a unit, right? And we said that if you want a unit vector, you can write it in trig form, and it was going to be this formula, because we proved yesterday how the sine of theta, we had our a and our b, and the sine of theta was b over h. So that means that the sine of theta is b. And so we could rewrite ab as cosine theta sine theta. Does that make sense? Okay, so if you want to rewrite that as a linear combination, you can just write it as cosine of theta I plus sine of theta j. Okay? Good with all that? All right. Let's do, whoops, wrong side. Let's do a couple of our examples here. Okie dokie. So we have the we want to find the component form with the given magnitude, okay? So, basically, you know what, go back to the first page. Let's talk about this one first. I'm sorry. I had a brain fart there. Okay, so basically, if you want to write a trig form of any vector, okay? So this was for unit vector, so it's placed at the origin, okay? But to do it for any vector, the only thing that's different is that you have the magnitude, so you've got your size involved, okay? So you can write that the magnitude of the unit vector, so that it is basically your magnitude times your cosine of theta and the magnitude of your sine theta. And the only difference for the linear combination is that you're going to then just cosine of theta I plus magnitude sine theta j. Does that kind of make sense? I do everything in the trig form. I very rarely use it in the linear combination. But when you take linear algebra in college, then you'll need to know that I and J stuff.
What's
So,
the probability that it will take a linear algebra in college? Like
27.43.
So that's small. So I probably don't-
That's over 1/4 of you.
Yeah, that's a.
Considering you're all saying none of you are going to take any math. All right, anyway, so let's find the component form, okay? And so we have our vector of AB. We can write it as a cosine of theta, sine of theta. And then we have our magnitude. So I'm going to rewrite it so that it'd be like saying I have 20 of vector cosine 225 sine of 225. Oops, so you can see it. You guys gotta tell me when that happens. Okay? So, what is the cosine of 225?
That's the one like this.
That's when you go, hey, I need my handy dandy thing. So, cosine of 225 is gonna be negative 2 square root of 2 divided by 2. And the sine of 225 is going to be the same thing at negative 2 square root of 2 over 2.
Where do you get the negative to?
It's negative 1.
Why? We went through this last time. Why did I do that yesterday? I did the same thing
You
yesterday.
are so silly.
Oh, so I see. Yeah.
Why do I see that like that? Wow.
I don't know.
What is it when you have blurred vision and you see two images of the same thing? But it's only happening when I see the twos.
That is called. What thing when people read things? I think it's like that.
See it?
Dyslexia.
It's
Now
not
that's
dyslexia.
switching the numbers at all.
You see like duplicates.
So anyway, okay, so now that I did that 2 days in a row, all right, so now this is like the scalar, so we're going to multiply. So it becomes negative 20 square root of 2 over 2 and negative 20 square root of 2 over 2. And then you have to simplify. So now negative 20 divided by 2 gives me negative 10 square root of 2. and negative 10 square root of 2.
Why are these boxes so small?
It's a lot of problems.
Didn't think.
I mean, she did.
Okay. All right, so how am I going to set up the problem for number 7?
Okay.
Hmm? Cosine 150 and sine of 150. What's the next step? So the first step is to rewrite in trig form. Okay, so convert the trigs to radicals. Will you? All right, so cosine of 150 is what? So negative radical 3 over 2.
And then the other one is 1/2.
Sine is 1/2. All right, third step's going to be to distribute and then simplify. All right, so I'm going to get negative 12 square root of 3 over 2 and 6.
Limit the negative 12 into simplify.
Yep, to negative 6 square root of 3 and 6. Need more room than that? Okay, so for the bottom part, are you guys good on those? Do you feel comfortable with those? Yes? Okay. Now, the second part here is basically the reverse. Okay, so we're going from A, B, and we want to put it back into the cosine form. Okay, so what did I need up here? What did I need up here to do down here? What information was I given? Yeah, the wheel, but why did I need the wheel? Okay, but what do I have when I rewrote it into here? What did I need? What was I looking? What information did they give me to start the problem? The degrees. So I'm looking for the angle degree, right? And what else was given to me? The magnitude. Okay, so how do I find the degree or direction angle? How do I find the degree or direction angle for one of the vectors? Go back to 2 skill quizzes ago. What did we do? It's a trick.
Is the answer trig?
Yes. Janice isn't very awake today. She looks sad. Not the square root, but the square root's how we find the magnitude. So that's great. Okay, the magnitude was the square root of a squared plus b squared, correct? Love that part. How do we find the degree? Remember when we were doing directional and you had to add 180 or add 360? Yep, that's exactly what it was. So it was your inverse of the b over a. And then depending on what quadrant, we followed the rules, right? All right, so Let's find our degree. So which one's A, which one's B?
Y is, or Y.
How about a number in the first problem?
8/15.
Okay, let's take that. All right, so that gives me my inverse of trig, so 8/15, and I get 28.07. Okay, which quadrant am I in? First quadrant. So what do I do for my direction angle? Nothing, right? Okay, so that means, hey, look, cosine of 28.07, sine of 28.07. I'm half done. Now all I need is just to find my magnitude. All right, so you told me how to find the magnitude. How do I find the magnitude?
15 squared plus b squared over that.
You like that one? Okay, so 15 squared plus 8 squared gives me the square root of 289. Do I have any perfect squares in there to simplify that bad boy? 3's not a perfect square, but 9 is. The 3 squared is
That's what I
9.
meant.
I know. Nope.
Nope.
What about, let's go up. What about 16? No. 17 squared. So that means that my trig form is 17 vector cosine 28.07 sine 28.07. Okay, good. Okay, so let's do the next one. Well, let's go down. How about number 11? What's wrong with what I have here? Non-component form. So how do I put it in component form? No. Remember back on the very first page, if I can find it under this pile of crap, where we were talking about here? What did we just do? Yeah, and added them. So that means I can rewrite it as -1, 7. Easy peasy. Okie dokie. Then, let's find our degree. So I'm going to find my inverse of 7 over -1. And I get -81.87. But what quadrant am I in? So what do I have to do? Add 180. Absolutely. So I'm at 98.13. And last but not least, what should we do? Magnitude. So I get -1 squared plus 7 squared. So 1 plus 49 gives me the square root of 50. What perfect square do I have in that one? 25. So that's going to be 5 square root of 2. put it in the formula. So I have 5 square root of 2 and cosine 9813 sine 9813. How do you guys feel about those? Yes, sir. Hi there. She is. I sure can. Bye. Oh, Miss Shanks. Do what? To the office. They just need you to run down there for a quick second. Okay. Mason, what was your question?
Why do we have to add the
Oh, you weren't here for that. Once we get going on the stuff, I will do the directional angles with you. How's that sound? Okay. What other questions? Yes? No? Okay. So then the rest of class, you have, look, all sorts of homework problems to practice this. Okay? So the stuff that was on the skill quiz yesterday was the adding and then doing the unit vector in the same direction. And then today is going to be just what we did with the component form and the trig form, right? So since the skill quiz tomorrow looks something like, imagine your skill quiz today that I gave back to you today, the front looking very similar, and then maybe adding one of these problems and one of these problems on the back page. I would practice on your homework for the next 15, 16 minutes. And we're going to have part work day in the beginning and then like do the skill quiz at the end because I have another review sheet for you. Cool? Sound like a deal? And then Monday.